Hello, my name is Gabriel and welcome to the City Structures channel. We've been looking at concrete design using the robot software, pretty much covered the analysis part, and finally we're going to begin design. In today's lesson, we're going to talk about the required reinforcement feature in robot. If you've used this software before, you'll definitely know what I mean. Now I'm not an expert on this software, but a couple of books, trials, and videos later, I think I can say a thing or two about it. So let's get to it. The required reinforcing option is a quick way to determine the steel requirements for your structure and can be used as a preliminary design. It calculates the area of steel required by the different members and provides steel based on the parameters you have set. In order to access it, you can either go to the layout tab here, just go to RC design, and depending on the members you want, so you can either do slabs or beams and columns, or you can go to design or the design tab and select it. So in our case, I'm going to be dealing with beams and columns, so I can click on this. So this layout, we're going to be dealing with 3 steps before we go and calculate. The first one is just to create and assign the member type labels. Secondly, is to create and assign the calculation options. Then lastly, we're going to select the members and load combinations that we shall consider when you are making the calculations. So beginning with the member type labels, you can go to this option here, RC member type. Now by default we have the RC column and the RC beam. If you want to create yours, you can just click on this new here. Now these are settings which are applied to members and shall be considered during calculation of reinforcement areas. So for the beams, for example, perhaps let's just create our own. You can say standard beam. So in this case, we are dealing with several parameters, just the geometrical definition of the element, that is at this point here. So we want to specify the span length. I wish it to be in the axis, so this is going to be where the joints of the beams are going to be, or are going to be found at. Then the support width, I'm going to keep it at according to story structure. Admissible deflection, perhaps I'm going to give it a value of, let's say, 25 millimeters. Then I'm not going to add any considerations of the T-beam. When I click on this, I'm going to make the slab that is attached to the beam to contribute to the strength of the beam, but I don't want to do that. Then for calculation of forces, Fx is the axial load. My and Fz, those are the most critical ones. Those are the shear force and the moment on the main axis, or rather the stiffer axis. Then Mx is the torsional moment, so I'm going to keep it as that. Then once I'm done, I can save it up, so it's added here. Then I go to the column tab. For columns, we're going to be dealing with the buckling lengths for the different axes. So for y-axis, perhaps I'll just keep them both within the axis. Buckling length coefficient, I'm going to keep it at 1. I'm going to rename it standard column, then just save it up. Then I close it. Next up, we're going to look at how to create and assign calculation options. To do that, just go to this icon here. So already there are 2 here, but I'm sure there's one, perhaps when you're using it. This one is already mine. Just close it. So let's create our own. So I can call it standard calculation, like that. So the first thing, we're going to set up the grade for the materials, especially for the concrete. So I can decide to be according to the structure model. So these are the grades I had assigned the different elements, or rather the beams and the columns, when I was modeling them, or I can decide to change them. So perhaps let me say class 25, unit weight, I leave it as that. Reinforcement check for cracking, yes, I want it to be checked. Maximum cracking value 0.3. Then exposure, let's keep it at mild. Longitudinal reinforcement, same thing. We're going to be determining the steel grid to be used, and the sizes of the bars to be used, both for the bottom and top reinforcement, and also the cover to the reinforcement. So in case you don't know how to set your own grade, can look at I think the second video, I talked about job preferences where we were defining the different material grades, material specifications. So in this case, I'm going to keep it as 460 grade T. Then the same bar diameter in both directions, can allow that. Let me keep it at T16. Then the cover, so as you can see, this is the steel. You can decide, let's add the clear cover to be around 25. Let's put it at 25, like that, such that the axis is going to be 33. It's okay. Then we go to the transversal reinforcement, and these are the same settings as the longitudinal reinforcement, perhaps just some additions here. So from the gradings, we're going to keep it at, let's use 250 here, or grade R. Then diameter of bar, I want it to be 8. Number of reinforcing sections, let's keep it at 3. Or rather, I can decide it to be 1. Now this is the number of different reinforcements that the shear links are going to be provided in, based on how the shear force varies within the structure. So if I were to select 2, it's only going to select 2 options for the reinforcement spacings. If I pick 3, it's going to do the same. For the modularity of spacings, this is just how the spacings are going to be provided. So for example, if it's 20 millimeters, the spacings are going to be provided in multiples of 20. So perhaps to 20, to 40, to 60, etc. So I can perhaps, let me say 25. Or I can also list the spacings that I want. Then on this setting here, now when you're considering shear reinforcement, you can also take into account longitudinal reinforcement to be adding some bit of resistance to shear. But in this case, I want to be conservative, so let's just keep it at that. Once it's done, I save it also, then I close. Then lastly, we're now going to select the members and the load combinations to consider. So you don't want all the members, you can decide that you want the beams and the columns. So perhaps let me just click on these 3 dots and select them. So let me select all of this, then select this and add it. So it's 1 to 13. Then for the combinations, so click on these 3 dots. I'm going to use combinations. So I want the ULS, add it there. SLS, I also want it to be just the SLS itself. Then I don't added any accidental loads, so I'm not going to use it. Then in this option here, calculating or determining the points, this provides the number of points in a beam, which calculations are going to be done. So in this case, we have 5 points. Those are very many points. So we can reduce them perhaps to 3. Before we even hit the calculate button, let's go down to this table here. And this table summarizes everything that we have selected for the members, starting from the materials, the type, the reinforcement parameters, and even the section itself. We can even decide to change the section right here. Then add initially selected that the material to be concrete class 20. So if I want to change all of it, I can just right click, rather select all first by clicking on this top part. If I want to change the material for all the sections, I just click on it, right click, then fill special. Then I'm going to determine it as class 25, press OK. That's going to change everything. Then for the reinforcement type, so consider that the calculation type is going to be different for the beams and the columns, so you have to select them individually. So we had said standard beam and standard column. So these are columns, we're going to use standard column. Then lastly, for the reinforcement parameters, I created only one standard calculation, so I can use the field special option here. Standard calculation, hit OK. So once you're done with that, you can now click on calculate. So we had changed the material properties, so we have to run the analysis once more. So in the calculation report, you can see there are no errors or warnings. So we close it. Now this table, this shows us now how the reinforcements have been provided. Now this is for all the members, or rather for the beams. So when you're talking about now the number of points, as you can see, if we were to select this beam, number 7, we have 3 points where the reinforcement has been calculated for. So as you can see, top reinforcement required this point, and this point. So it goes on all through, providing for those points. Then we have now the bottom reinforcement distribution, how the bottom reinforcement has been provided, then the top on this side, then we have the transversal reinforcement distribution. So if you wish to view more values, you can just right click on the table, then add columns. So perhaps you might decide you want to see the required reinforcement ratio, the provided. The required is going to be code based, most likely. Then the provided, this is how much has been provided. So you can check out perhaps whether it's economic or not using these ratios. Then moving on, we go to the columns. Still also the same thing. So if we select column 1, this column is here. It'll show you the required reinforcement along the length B, then along the length H right here. Then the reinforcement provided, so 2 T16s and 2 T16s, and also the transversal reinforcement. You can even add other columns by right clicking the table, then just add another value that you wish to check out. Just add this, or rather let me add this one. So as you can see, the required reinforcement here is 60. Then what we've provided along B, that's quite a lot. So I can even determine the reinforcement ratio required and provided. Let me close these ones. Let's use the ratios. So the one required was 0.4. This is code based. Then we provided 1.34. So in conclusion, the required reinforcement option offers a starting point for design. However, it does not perform other checks like the anchorage lengths, the maximum and minimum bar spacings, and also reinforcement for shrinkage are not considered. In the next video, we shall look at provided reinforcement option, which is more detailed for providing reinforcement. If you found this video useful, don't forget to like and subscribe to the channel for more content. See you in the next video.